Analyze the molecular structures and bonds of reactants and products. Reactants. The reaction begins with 2 moles of hydrogen peroxide, H2O2. The molecular structure of H2O2 is HOH. Therefore, 2 moles of reactant contain, for moles of OH single bonds, 2 moles of low single bonds products. The reaction yields 2 moles of water, H2O, and 1 mole of oxygen gas, O2. The molecular structure of water is HOH. Thus, 2 moles of water contain 4 moles of OH single bonds. The molecular structure of oxygen gas is O equals O. Thus, 1 mole of oxygen contains 1 mole of O equals O double bonds. Set up the relationship between bond enthalpies and reaction enthalpy. Delta H degrees. The enthalpy of a reaction can be estimated by subtracting the total bond energy of the bonds formed, products, from the total bond energy of the bonds broken, reactants. Delta H degrees approximately sum D broken. Sum D formed. Delta H degrees approximately 4 times D OH plus 2 times D O. For times D OH plus 1 times D O equals O. Simplify the mathematical expression using the given assumption. The question states to assume that the bond enthalpies of the OH bonds in H2O are not significantly different from those in H2O2. Because of this, the 4 times D OH term on the reactant side and the 4 times D OH term on the product side are essentially equal and cancel each other out. This simplifies our delta H degrees expression to delta H degrees approximately 2 times D O. D O equals O. Substitute the experimental delta H degrees value to find the numerical target. We are given that delta H degrees equals minus 196 kilojoules per mole of reaction. Substituting this value, minus 196 kilojoules per mole approximately 2 times D O. D O equals O. This tells us that the bond energy of 1 mole of O equals O double bonds must be approximately 200 kilojoules per mole larger than the energy required to break 2 moles of OO single bonds to make the reaction exothermic. Test the given options using the simplified relationship. Let's substitute the values from option B into our simplified equation. D OO equals 150 kilojoules per mole and D O equals O equals 500 kilojoules per mole to 150. 500 is equal to 300. 500 is equal to minus 200 kilojoules per mole. This result is extremely close to the experimental value of minus 196 kilojoules per mole, identifying option B as the correct choice. The correct answer is option B. O in H2O2, 150, O equals O in O2, 500, O, H, 500.